this is Aruna, working as Associate Professor in Aditya University. Let us start with electrochemistry, and the topics that I am going to discuss is batteries and their applications, and in these batteries let us discuss about secondary batteries and their applications. First of all, let us discuss what is a battery. Battery is nothing but a galvanic cell where the chemical energy of a redox reaction is converted into electrical energy. So, once again I repeat, it is nothing but a galvanic cell where the chemical energy is been converted into electrical energy. This energy is stored in the cell and can be used when required. So, we all know that a battery is one which supplies the electrical energy, and this energy is supplied due to the redox reaction. There are two main types of batteries. These are primary batteries and secondary batteries. So, batteries have been divided into two types. First one is a primary battery and second one is a secondary battery. Let us discuss what is a primary battery. This primary battery is also known as a primary cell. In this primary battery, the cell reaction is irreversible. So, once again I am repeating, in a primary battery the cell reactions are irreversible. Once the cell reaction has taken place and the reactants have been converted into products. So, we see that in a primary battery the reactants have been converted into products where the reverse cannot happen. Hence, it is known as we can see that in a primary battery the cell reactions are irreversible. Let us see what is a secondary battery, which is also known as secondary cell. In these batteries the cell reactions are reversible. So, we see that in a secondary battery the cell reactions are reversible once the forward reaction occurs and the cell is discharged. So, during the giving of electrical energy, we see that the forward reactions are taking place. It can be charged again by applying external potential. So, after it discharges electrical energy, we can also make it charged by applying external potential. Let us see the working of one such secondary battery, which is known as zinc air battery. Let us see the working of zinc air battery. Here the zinc air battery consists of anode which is been made up of zinc plates, and a perforated carbon plate is treated with water repellent acts as cathode. So, here we take zinc plate as anode and carbon plate which is treated with water repellent acts as cathode. Sodium hydroxide or potassium hydroxide is used as an electrolyte. So, here we have used sodium hydroxide or potassium hydroxide as electrolyte. The anode and the cathode and the electrolyte are contained in an ebonite or polymer case. So, this entire setup of anode, cathode and electrolyte are taken in the ebonite or polymeric case. At the anode, zinc reacts with electrolyte to form zincate ions. So, we see that zinc which is going to act as anode reacts with the electrolyte to form zincate ions which decay into zinc oxide and water. Here the electrons released at the anode travel to the cathode, where oxygen of the air accepts the electrons to form hydroxide ions. So, we see that the electrons which are given by oxidation at anode travel to the cathode, and at the cathode we see that oxygen reacts with air accepting the electrons to form the hydroxide ions. So, we can see all these represented in the form of cell reactions. So, now we can see the cell reactions which are taking place at anode. Here we can see that zinc combines with the hydroxide ions which are obtained from the electrolyte to change into zinc oxide, and then water and electrons. So, these electrons travel and reach the cathode, where at the cathode we have oxygen supplied which combines with the water that is present in the electrolyte solution, accepting the electrons to change into the hydroxide ions. So, we see that the net cell reaction is zinc combines with oxygen to form zinc oxide. This is the overall reaction taking place during the discharge of electric current, where zinc combines with the oxygen, changing into zinc oxide. So, this zinc air battery produces nearly about 1.65 volts, and these zinc air batteries have properties of both the fuel cell and batteries. So, we can see that fuel cell is an advanced cell. So, this zinc air battery not only is an example for a secondary cell, we can see the combination of both the fuel cell and batteries. They are electrically non-rechargeable. So, we have to remember that this zinc air battery is non-rechargeable electrically, and they can be recharged using mechanically. So, here this battery cannot be recharged using electrical energy, but it can be recharged mechanically by converting the zinc oxide produced in the battery back into the zinc metal. So, when we use mechanical energy, this zinc oxide once again gives back into zinc metal. That is how the reactions can be reversed using the mechanical energy. So, here we have a picture showing the zinc air battery. So, here we can clearly see that the anode is been placed with a zinc plate, and air is been supplied at the cathode, and we have an electrolyte solution which is 5 molar sodium hydroxide, or we can also take 5 molar potassium hydroxide. And here we can see that zinc plate has been directly taken as the anode, and the cathode is been made up of carbon which is treated with water repellent, and we can find that it is having fine perforation, so that air can simply enter into this cathode. And in between anode and cathode, we can see the 5 molar sodium hydroxide or 5 molar potassium hydroxide. Once the setup is there, we can see that zinc undergoing oxidation, where electrons are transferred from the anode to cathode, and at the cathode we see air sent, where we have in the cathode oxygen entering through the perforation, and electrons accepting from the anode, and we have the reduction reaction taking place. So, electrical energy is produced until we have oxidation and reduction taking place at both the electrodes. Now, let us discuss about the applications or uses of the zinc air battery. They are very cheap. So, we can see that these secondary batteries, especially the zinc air batteries, are very cheap, and they are obtained in small size, small button size, which are being used in watches and in hearing aids. We can also have these batteries in large size, where large batteries are used in cameras and also for the electrical propulsion of vehicles. So, we are having a huge number of applications. Here I could discuss only few applications. So, we can see that these are the cells which are obtained in small size as well as large size. The small size batteries have been used in equipment in instruments like the watches and hearing aids, whereas large batteries are used in cameras and in electric propulsion of vehicles. Now, let us discuss about another such a secondary battery, which is very important. So, out of all the commercial batteries, we see that they do not have enough of performance in many applications. Hence, we need a battery which can supply continuous electrical energy. So, a continual exists for both the conventional battery technology with improved performance and advanced battery technologies which have characteristics such as a high energy level, long life, low cost, no maintenance and safety. So, there is always a requirement to have a battery which is having high energy level, long life, low cost, no maintenance and safety. Chemical reactions in secondary cells are reversible, as we have already discussed that all the chemical reactions that take place in a secondary cell are reversible and hence they can be recharged. So, we saw the zinc air battery which can be recharged with mechanical energy. So, now let us take the advanced cell and let us see how it is getting recharged. So, here we have few examples for the secondary cells like the lead acid battery and nickel metal hydride cells. So, now let us see the working of lithium batteries. In lithium cells, lithium metal acts as the anode due to its lightweight. So, we see that lithium batteries, we have directly used lithium which is going to act as anode. The reason for choosing lithium metal is due to its lightweight, lower electrode potential and good conductivity. So, the reasons why we have selected a lithium metal as anode has reasons like lightweight, lower electrode potential and good conductivity. Lithium cells are safer, cheaper and non-toxic that exhibit high performance. So, here we see that lithium cells are the secondary batteries which are being the safe, cheaper and non-toxic. Beside all this, they also have high performance. Lithium ion batteries are rechargeable batteries in which lithium ions move between anode and cathode. So, in a lithium ion battery, we see that the lithium ions move from anode to cathode during the oxidation and reduction reaction, and it can produce an voltage of 1.5 to 3.7 volts. So, in lithium batteries, we see the potential is around 1.5 to 3.7 volts. In this lithium batteries, the most important is the lithium ion cell. So, this lithium ion cells also comes under the secondary rechargeable batteries where lithium acts as cathode and graphite acts as anode. So, here we choose lithium as a cathode and graphite as anode. These migration of in this cell, we see the migration of lithium ions between two electrodes. As it is mentioned already that lithium ions move from anode to cathode. So, in this lithium ion cell also we see that there are lithium ions moving from anode to cathode between the two electrodes through a lithium based salt as an electrolyte. So, here we have not used any sodium hydroxide or potassium hydroxide as an electrolyte. Instead, we have selected the lithium based salt as an electrolyte. So, the salts that have been selected as electrolyte are lithium hexafluoride phosphate or lithium tetrafluoroborate. So, we have selected a salt of lithium, that is lithium hexafluorophosphate or lithium tetrafluoroborate, which has been dissolved in ethylene carbonate. So, we have not dissolved these salts in water, instead we have dissolved them in ethylene carbonate. The reason for why we have not selected any electrolyte solution which are soluble in water is lithium is highly reactive with water. So, we have to remember that in the lithium ion cells we have not selected an electrolyte like sodium hydroxide or potassium hydroxide. Instead, we have selected a salt like lithium hexafluorophosphate or lithium tetrafluoroborate which have been dissolved in ethylene carbonate. Both the electrodes allow lithium ions to migrate towards and away from them. As we know that the lithium ions move from anode to cathode, here also the lithium ions move from anode to cathode. When the lithium ion cell discharges, the positive ion is extracted from the negative electrode, that is graphite, and inserted into positive electrode, and we have intercalated lithium compound formed. So, here we see during the oxidation and reduction reaction taking place at both the electrodes, lithium ions get intercalated with the graphite rod. Let us see the chemical reactions that take place during the oxidation and reduction reactions. At anode, we see that lithium intercalated with graphite, giving graphite and lithium ions and electron. So, these electrons move from anode to cathode, where the cathode is been made up of cobalt oxide, accepting the lithium ions and electrons, changing into lithium cobalt oxide. So, the overall reaction is graphite rod intercalated with lithium, having a coating, or simply we can say that a graphite which has been coated with lithium combines with cobalt oxide to change into graphite and lithium cobalt oxide. So, this is how the electric current is being discharged during the oxidation and reduction reaction, and we can see that until and unless this oxidation and reduction reaction taking place, we have electrical energy produced. Here we have a picture showing the working of lithium cells, where we have the anode made up of graphite, and while the lithium ions moving from cathode to anode, we have intercalation of this graphite with the lithium, which is lithium intercalated with graphite, and our cathode is cobalt oxide, and in between the anode and cathode we have the electrolyte solution, a lithium salt which has been dissolved in organic solvent. So, this has already been mentioned. Now, we have a pictorial representation of the lithium ion cell, and during oxidation we have electrons produced at the anode, and they move from anode to cathode, and at the cathode we have the reduction reaction taking place. So, in this way we have electrons moving from anode to cathode, and hence the electrical energy is produced due to the redox reaction. So, now let us discuss what are its advantages. So, coming to the advantages, we can see that they can be formed into a wide variety of shapes and sizes, so as to effectively fit the available space in the device they power. So, now we can see that these lithium ions are obtained in different sizes and shapes. Wherever we need whatever space that is been provided, they can easily fit into that space. They do not suffer from the problem of effect. We do not have any problems that have been faced during the working of this battery. They have a voltage nearly 3 times the values of typical nickel based batteries. So, their performance is 3 times more than the nickel based batteries. The self discharge rate is very low. So, we can see that they do not get discharge at a discharge rate is very low. So, you can have a good supply of electrical energy produced from these lithium ion cells. And coming to uses, these lithium ion cells have been used in electronics, toys, wireless headphones, handheld power tools, small and large appliances, electric vehicles and electrical energy storage system. So, here I have mentioned only few applications which have been widely used. So, we see that these lithium ion batteries have been used in the electronics, in making of toys, in the wireless headphones, handheld power tools. So, we see that these cells have been used in small and large appliances. They have been also used in electrical vehicles and electrical energy storage systems. Now, let us discuss about another secondary cell which is known as the nickel cadmium cell. So, this nickel cadmium cell is a recently developed rechargeable cell. So, this has been developed recently, and in this nickel cadmium cell we have a cadmium rod which acts as anode. So, we have selected cadmium as anode in nickel cadmium cell, and nickel oxyhydroxide which has been taken, nickel oxyhydroxide which has been taken as a paste acts as cathode. So, once again in this nickel cadmium cell is the recently developed cell where the cadmium rod acts as anode, and nickel oxyhydroxide which has been taken as a paste is acting as cathode. And this has been filled with 5 molar potassium hydroxide solution which acts as electrolyte. Since cadmium do not have any reactivity with water, once again we have taken 5 molar potassium hydroxide solution which acts as electrolyte solution. So, coming to the oxidation and reduction reaction that take place in the nickel cadmium cell. So, cadmium which is been taken as anode combines with the hydroxide ions from the electrolyte solution, changing into cadmium hydroxide and giving away to electrons. So, this is the oxidation half reaction that take place at the anode, and these electrons move from anode to cathode, where nickel oxyhydroxide combines with the water that is available in the electrolyte solution with the electrons changing into nickel hydroxide, and giving away two hydroxide ions. So, here we see that cadmium is undergoing oxidation and nickel oxyhydroxide undergoing the reduction reaction. So, during this oxidation and reduction reactions, we have electrical energy produced. So, this nickel cadmium cell potential in the reactions can be readily reversed as the products nickel hydroxide and cadmium hydroxide stick to the electrode surface. So, here if you see we have the byproducts like cadmium hydroxide and nickel hydroxide produced, and these both the hydroxide stick to the surface of the electrodes. Hence, that is the reason why how we can reverse these reactions, and it is small and light in weight with a cell voltage of around 1.4 volts. So, here we see that this nickel cadmium cell reactions can also be reversed, and they are also small in size, light in weight, and the potential is around 1.4 volts. The cell works for a long period without deterioration. So, we can see that this is giving a very good output for a long time without undergoing any deterioration or charging, and we see that no gases are produced during the discharge of electrical energy. That is also one of the advantage we have using this nickel cadmium cell. We see that no gases are producing during the discharge of electrical energy. Now, let us discuss some of its uses or applications. So, this cell nickel cadmium cell is being used as high power applications. We can make use of these cells producing high power, and especially in power tools. So, this nickel cadmium batteries are favored for their ability to deliver high surge currents and stable output for power tools like drills and saws. So, we see that these nickel cadmium batteries, since their output is high, we can see that they have been used in power tools like drills and saws, and it is been used in emergency lighting and backup power. They are used in emergency lighting system and backup power applications due to their ability to hold a charge, provide stable power output, and withstand deep discharge cycles. So, these cells have been used in emergency lighting and backup power just because of their ability to give a continuous supply of electrical energy. And the other application is in aerospace and military applications. Their durability and performance under extreme conditions make them suitable for aerospace and military equipment. So, these batteries, since they have durability and they can perform under any temperatures, under any extreme conditions, as they have been used in aerospace and military equipment. These are also been used for the UPS systems. So, nickel cadmium batteries have been used in uninterruptible power supply systems for many years due to their robustness, high discharge rates, and long cycle life. So, due to their high discharge rates and long cycle life, they have been used in uninterruptible power supply. So, here we have a picture showing the nickel cadmium cell, where the anode is been made up of cadmium and the cathode is nickel oxyhydroxide, and the electrolyte solution is 5 molar potassium hydroxide, and the electrode and electrolyte have been placed in the polythene case, and we have a separator in between the anode and cathode, and hence we see that at anode oxidation takes place, and at the cathode the reduction reaction taking place, giving the electrical energy. So, finally, I would like to summarize this that students will be able to understand what is a battery and what is the difference between a primary and secondary battery, and how the working of secondary batteries like the lithium ion cell and nickel cadmium cell taking place and their applications. Thank you.